my book covers AC safety, it covers lightning protection, and it covers RFI in the shack. So this part of the talk is going to cover the 2 second parts of the book. And also, as long as I'm mentioning books, Ron Block, who was one of the Polyphaser, he wasn't a founder, but he was an early employee there. He's written a new book that's available called Lightning Protection for the Radio Amateur. And he goes into great detail on lightning protection, and it's available online. I just wrote a review of it for QST, so that's the ordering information is there. Very good. And Ron also wrote a couple of the really good articles that are in ARL website. So, in-station bonding for home HF stations. There's my favorite book. And Ron was one of the reviewers for the book, and it was the reviewers that really added a lot of value. Ron Block, Jim Brown, Dale Svetnoff, WA9E&A, the ARL lab. All those guys contributed quite a bit to making sure that the advice was correct and complete, and I didn't give contradictory advice in different parts of the book. So it's not a cookbook. This is too complicated. Everybody has different circumstances. It's a toolbox. So we talk about the tools and how to use them, and then you go home and you go, okay, well, what am I going to do? And how much money do I have? And how much can I get away? I mean, no, anyway, how much can I do at my station? So that's what you do. Okay, so let's talk about bonding. All that bonding is a connection intended to keep 2 points at the same voltage. That's it. You go look it up. Even in a sophisticated professional dictionary, that's what it is. And so Jim touched on this, and you'll see me do this a bunch of times. Everything goes up and down together. And when everything goes up and down together, you don't have voltage differences. What causes current to flow? Voltage differences. So if you don't have voltage differences, you minimize current flow. And that's true for AC safety. It's true for lightning protection. It's true for RFI. It prevents shock hazards from voltage differences. If you have a fault, a short or something in your shack, and everything is connected together and it's connected to the safety ground, then everything stays at the safety ground voltage. So it prevents electrocution. And lightning surges, as Jim alluded to, when you get a lightning current, and I don't know about you, but when people start talking about kiloamps, I get nervous, okay? I'm a circuits guy. I'm not a power guy. So kiloamps, that's a lot of energy. So these current surges, if you have everything bonded together, and you get a big current surge through it, you still minimize the voltage difference. And the voltage difference is what drives the current that causes the damage. So bonding minimizes destructive voltage differences. And it limits current between devices, even if you're not getting hit by lightning. You're out there, you're transmitting or something like that. You still got RF coming into your station, and the station will pick up all kinds of RF. And RF voltages are what drives the current, and the current is what causes RFI, current getting into something that it should not get into. That's what RFI is. It's not the voltage, it's the current. So if you minimize the voltage, you minimize the current because everything's going up and down together, and it really helps for RFI. Okay, is bonding hard? It sounds hard. It's like you've got to use fancy stuff and expensive materials. It's not. It's really easy to do. Once you figure out how to do it, you go, that's a no-brainer. I can do that. But you do have to use the right connecting materials and hardware. None of them are very expensive. And when you do the bonding and you do it right, you can work in your favor for all three of those types of requirements: AC safety, lightning protection, and RF management. You don't have to build one system for AC safety, one system for lightning protection, one system for RFI. If you do it right, one ring to rule them all, you save yourself a lot of trouble in all three of those domains. Okay, for bonding to work, it has to be low impedance, talked about that a little bit. And it has to be electrically short at the frequencies of interest. At AC, the wavelength is like 50 million meters. So short can be something the size of a football stadium. But when you start getting up into lightning's upper ranges and RF, then the wavelength is much shorter. And for something to be considered electrically short, it needs to be much less than about a 20th of a wavelength. So 20 meters. What's the wavelength of 20 meters? Trick question. Not all at once. Okay, 20 meters, 60-something feet, right? So a 20th of a wavelength is about 3 feet, and you want it to be much shorter than that. So if you are going to have a bonding conductor and you're going to expect it to work at 20 meters, it's got to be much less than 3 feet. None of these big, long, 6-foot, 10-foot things. It also has to be heavy enough to carry the expected current. If we're talking about lightning protection, and we're talking about kiloamps again, it has to be fairly robust. And that's why you have to use number 6, number 8, number 10, number 2, whatever. If you look online, there are some really interesting YouTube videos about what happens when you run really high current through conductors, and the Coulomb force, which is this magnetic force on the conductor, can be hundreds of pounds per foot on these things, and the wires will rip themselves out of holders and walls and move around under these stresses, mechanical stresses. So the wire has to be able to stand the load, has to be able to carry that current without turning into a nice green lightning bolt, and I think we've all seen that, okay? And it has to be sturdy mechanically enough to get hit and not tear itself apart. And also, if you're outside and you're burying things, it has to be sturdy enough to survive the environment, which means you're going to drive over it. You're going to dig it up accidentally. You're going to trip over it. You're going to dig it up with the rototiller. Don't ask me how I know that. Okay. And so it has to be heavy enough to survive those mechanical insults. Frost heave is another problem, and you don't want that to break your ground connector. There's no real visual indication that says, oh, my ground has been broken, but you may not have a ground. You may not be connected the way you think you have to be. So you have to use heavy direct connectors, and that's why your building codes specify number 8, number 6, number 4. It's not just to buy copper, it's so that it will survive in the environment. Inside your station, what do you use for bonding? The commercial military standard is a copper strap that's 20 gauge, meaning the thickness, and about 1 inch or 1.5 inches wide. You will see wider straps and heavier straps, but what the basic lowest common denominator is a copper strap that's 20 gauge. You can use number 14 wire as well. That Romex that's under the garage workbench in the box, that's perfectly good. If the strap gets too wide, similar effect to skin effect takes place, and the current is pushed to the sides of the strap. So once you get beyond about 1 inch or 1.5 inches, you're not doing anything but buying a lot of copper. You can use the flat weave tinned braid that you can find at auto parts stores and various places like that. It's the silver stuff with about 1/2 inch up to about 1 inch, and that works really well. You can use that if your equipment's got to move around or in a mobile station. Remember that you don't want to use exposed braid from old coax. Why is that? Okay, it's got a plastic jacket that goes over all the nice little braided wires. What is the jacket's function? It's to hold all those wires together very firmly and to keep them away from oxygen and water. And those two things will degrade copper. So if you take the jacket off, you've got this old piece of coax, you go, man, that'd make a great ground strap. Okay, don't do that, because you take that jacket off, the instant you take it off and you loosen it to get the center conductor out so you can use it as a high voltage connector. I do that. Okay, you've already loosened up all these little connections and they start degrading. So it looks nice, but eventually it starts becoming worthless. It's a noise generator, and always keep your braid dry. Water is the enemy of any kind of braid. So protect your braid, leave it inside the jacket if you want to use that old piece of coax, and just waterproof it on each end, put a terminal on there, and it becomes a very fine BAW, big ass wire, okay? And just use that piece of coax as a big grounding wire. Okay, here's our single point ground panel. This is a typical single point ground panel. This is from the second edition of the book. And you can see it's just a big metal panel. It can be aluminum, it can be copper if you want to spend the money, but basically it's typically where the cables come into the house. Some people put them in a little garden shed or a truck toolbox outside, whatever, and you bring everything to this same point. Hopefully it will be close to your AC safety ground rod. Then that's usually standard construction now, but it seems like with hams, it's federal law somehow that your station is all the way on the other side of the house from the AC panel. But anyway, you put everything on this panel. All of your arresters go on this panel. Your lightning arresters for feed lines, your data, your phone, all that kind of stuff, and even an AC power protector is mounted on this panel. And then you've got the cables that come into it are unprotected. Those are the ones that are exposed to lightning. Those are unprotected cables. And then the ones that are on the other side, the downstream side of your protectors, those are protected cables. You want to keep the unprotecteds away from the protecteds. Even though it looks nice to bundle them all together, if you bundle them all together, lightning will jump from the unprotecteds to the protecteds and go around your protectors. Did I use the word protect enough in that sentence? Okay, so you want to make sure you've got a bundle of protected stuff and a bundle of unprotected stuff. And those are connected to your external ground electrodes or rods, and the NEC is unequivocal. They all shall, there's no wiggle room in shall, be bonded together. And that means you run a big number 6 or whatever between all of your ground rods, because otherwise, what are they connected with? They're connected with dirt, okay? What is the resistance of dirt? Dirt has a lot of resistance. So if you get 1,000 amps from a lightning pulse flowing through dirt, you can get thousands of volts between your ground rods. So what you do is bond together, and that creates what's called a perimeter ground system. When you bond all of the stuff together and connect it to your perimeter ground, all of your protectors fire at the same time. Ron Block pointed this out. This is really, really important. You've only got a few microseconds in this lightning pulse. Okay, so you don't want one ground to get a big pulse, and then maybe later another one gets a big pulse. You want them all to be at that same voltage going up and down together, and you do that by placing all of the arresters together. And then your whole system goes up and down together. Minimum voltage between these different conductors. This includes your non-RF and your AC power. So you want like a trip light power protector, not just like a power strip. You want an actual power protector. They're not that expensive. 35, 50 bucks, metal box, you mount them on this panel, and then you run your branch circuit to the protector, and then you run another power cable to your station. And it typically only takes one branch circuit to run most ham station equipments. Amplifiers, you have to run a second circuit. And we keep protected and unprotected cables separate. So here's an example. This is K4RO's single point ground panel. Kirk lives on a hilltop west of Nashville. Hams always live on streets that have like Scenic View Drive, Tower Hill, Sunset Ridge, and all this kind of stuff. So he's up there, and he was getting nailed by lightning regularly, and every time there was a big thunderstorm, he would lose some piece of equipment. So he finally said, I'm done with that. And he's got one of these 2-level houses where you drive into the garage. This is in the garage, and his station's right above this panel. So all of the stuff, all of his antennas, feed lines, everything come to this panel through the wall. It's one big piece of aluminum, and he mounted everything associated with the antenna system on that panel. And you can see switches, filters, all kinds of stuff there. And then his ground wire is up at the upper right. You can see that copper wire going through the wall to his ground system. And since he's done this, he's lost no pieces of equipment. Been years. So it's definitely day and night situation. Here's a couple of single point ground panels. I have several at my station because my station is also on a high spot, and it also has burned trees and all sorts of things. And I know the towers have been hit, 60-foot towers. And so I have several of these panels, one at the base of the tower, one outside the house, and one actually in the station to make sure everything is really thoroughly bonded together. And so I have a big metal rack, and I put everything associated with the antenna system and the amplifiers and all that stuff is in that rack. And you can get those racks for free, pretty much. You just got to make yourself known, and they will say, get this stuff out of here when they are redoing IT or something like that, and you go get it and haul it away. And on the back, you can see a couple of big panels there on the right where I have power switching and an antenna protector, and that's all bonded together, and then it goes out to the perimeter ground system, which is just a few feet away. This is from Ron Bach's 2002 QST articles. He talks about what's called a protected zone or zone of protection. And so you figure out what you want to protect, and you get a piece of paper, and you write a little box and make a little box for every piece of equipment. He's even got a wall clock on here, one of those little alarm clocks that's up at the top. Your TV, your tuners, your radios, everything, you put it inside the box. Everything you want to protect, you draw a line around it, and you show each connection to each one of these boxes. Everywhere one of those lines of connection crosses that red line, you have to have protection. Those cables must be protected somehow. Either they have to be powered from protected power, or they have to have an antenna protector or something like that, because the one that you don't, that's where lightning will get in. And if lightning gets into these zones of protection, it's just as bad as if you weren't protected. So basically read his articles. They're free. They're on the ARL website. Just search for Ron Block and you'll find them. July, August, September 2002 QST. And he's the same guy that wrote the book I just told you about. Okay, let's jump over to RF management. You have to remember that everything in your station is an antenna. And as we all know, the more you don't want something to work as an antenna, the better it will work as an antenna. And it's just the way it is, okay? So let's think about this. You've got a 40-meter dipole in the backyard. What's the wavelength of 40 meters? Oh, now we're getting somewhere. We're cooking with gas. Okay, 40 meters is about 130 feet. If your station is within 130 feet of that dipole, you are less than one wavelength from the antenna. You're in the near field, even though you can't see it and it's way out there. So you're going to pick up RF. You're going to light up every stinking wire in the shack. Your feed lines, your protected cables, your RF bonding conductors, all this kind of stuff. Your mic cord, you are conductive, so you're going to pick up RF too. So you got to forget about keeping RF completely out. Certainly there are hot lines that you can put some ferrite on and things like that to help, but everything is going to try to pick up RF. Then we talk about an RF ground. Why don't you forget about that term? It's really not possible to make a single point in your station that is 0 volts at RF over the frequency range that hams operate. We go from 160 meters to daylight. Okay, so it's not going to be possible to create a quote RF ground. Concentrate instead on bonding. You don't want 0 volt absolute. You want 0 volt difference. Okay, so you're trying to keep everything at the same voltage, whatever that voltage is. And it's just like in an airplane. How many people have seen an airplane dragging a chain to contact the earth? No, not very many. Okay, so everything in an airplane is bonded together. You've seen pictures of lightning going through a plane on the way to the ground. Everything in that plane went up and down together, and it's kind of the same for a ham station. You want everything going up and down together. They're all bonded together. Your connections are all electrically short. You're not running big cables over here and around here and back to a point on the wall. Keep everything at the same voltage. If you add an amplifier, not only are you going to meet the neighbors, but you'll also have high RF field strength. You'll find all the weak spots in your bonding. Trust me on that. So you have to pay extra attention to bonding. And so you can do this. The easiest way to do this is by creating a common reference plane, meaning basically a metal sheet under or next to the equipment, or some kind of a bus. and we've all seen this picture in the handbook for many years, was we go get a 1/2-inch copper pipe because that is the cheapest copper pipe we can possibly get, and we put it in the back of our station, and then we run a short wire from all the equipment to this copper pipe, and then the copper pipe is connected to our single point ground panel. When you connect to this copper pipe, if you use this technique, do not use hose clamps. Hose clamps are not made for metal-to-metal connections. They're made for holding some flexible material, like a hose, onto some inflexible metal pipe or tubing. Okay, if you put two pieces of metal together and hold them together with a hose clamp, you'll be amazed as thermal cycling occurs how that clamping action will loosen up. So these are not really good for ground connections. You can use sheet metal screws and terminals. If you use terminals, use tooth lock washer terminals. And when you clamp them down, they will bite into the metal, and that makes a good electrical connection. The little split O's are just not very useful electrically. Use the tooth, internal or external tooth. And you can also use ground clamps that are made for ground rods, because a 1/2-inch ground rod is pretty much the same size as a 1/2-inch piece of copper pipe. So you can actually go out and get a big one of those contractor bags of acorn clamps or something like that, and you can use those. Another thing I've been using is the ground bars that you can buy for the AC service panels. If you go to the service panel part of your hardware store, you'll see these silver bars up there. Some of them have 5, some have 7, 9, up to 20 something, and they're made for connecting the ground wires in your AC wiring to the neutral bus and the ground bus of your AC service panel. They're pretty cheap. They're sold in volume. They're not specialty items, and those make really good ground connections as well. When you are doing your cabling and you look back at the back of your equipment, the first thing you got to give up is this notion that you're going to get rid of ground loops. Ground loop is any conducting path between two pieces of equipment around between a couple of cables. And you can't get rid of that in a ham station. Even a modest ham station is going to have dozens of ground loops. Just in this little this little drawing here, there are more than 24 possible ground loops in this. So don't worry about the ground loops. You're not going to get rid of them, but you can bond to short them out. And that's what bonding does for you. It makes you less sensitive to these ground paths. Use the shortest cables you can and coil them up. And if you coil them up in a figure 8. If you coil them up in a figure 8 and you expose the coiled up cable to a magnetic field or an RF field, the voltage that's picked up in each half cancels out. So if you just coil it like this, it's like a secondary of a transformer. But if you do it in a figure 8, you can cancel out a lot of that voltage. You want to put your cables on the bonding bus or a ground plane, and I'm going to show you the reference plane here in a minute. You always use shielded cables, even if it's just for a switch, because it's going to pick up RF and it's going to go on those switch wires, and whatever you have that switch connected to, that's where the RF is going to get in. So always use a shielded cable if you can. And short straps or wires, they shouldn't do this. I realize that's not always possible, but they should be as short as possible. This is what a reference plane looks like. You can see the shiny thing under the monitor there. That's at one of my stations. It's basically a Costco table, a poor defenseless Costco table. And I went out and got a roll of aluminum flashing. Okay, it's the cheap stuff at the store, and I just laid it on top of the table and took a drill and some sheet metal screws, pew, 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 and that's my ground bus. That's it. There's also a ground bus in the back that makes it easy to connect the ground wires to. And I've laid all the cables on that, and so that reference bus makes sure that everything is at the same voltage when RF comes to visit. Here's a picture of these ground bars. I didn't know if I had that in there or not. The thing at the lower right, that's a 15 maybe, for 15 position ground bar, and that would be bolted into an AC service box. It costs about $3 or $4. You put that right on the plane, you screw through the bus into the plane, and you use external tooth lock washers to make sure that you have a good connection It stays there. And then over at the right, you can see my BAW that is connected from the reference plane, and it goes out to the perimeter ground system, which is a few feet away. And there's a big terminal, stainless steel hardware, external tooth lock washer. Okay, additional resources, and these are out there. The National Electrical Code was written by the National Fire Protection Agency, which tells you a lot about what they were trying to accomplish. In the early days of electrification, there were hundreds of fires and electrocutions and all this kind of stuff. And so the fire people said, we got to deal with this, and they own the National Electrical Code. The International Association of Electrical Inspectors is another good website, and that tells you what they're looking for, and there's some training and guidelines on there. Mike Holt Enterprise. Mike Holt is an ex-electrician. He now trains electricians, and so there's a ton of free stuff on his site, a lot of good drawings and rationale for simple things to do. And then Polyphaser, because the founders were hams, they wrote a lot of white papers, and there's still stuff on the Polyphaser website. And then for those of you who are really interested readers, the standards that are used to generate this stuff, the Motorola R56 standards available online as PDFs all over the place. That's for VHF and up communication sites. The FAA document on practices and procedures. It's 6950.19a, and that tells you how they construct their communication site. IEEE standard, if you're a power person, it's expensive, but you can get it through the libraries, and that really tells you everything you want to know about power system grounding. And the Mill Handbook 419A, Jim referenced this in his talk, that is how the military builds their HF communication site. Now, you don't have the budget they do, so basically what you do is you look at these standards and the books that are written from these standards, and you go, okay, what are they telling me to do? And then you look at your resources and your materials and wherever you are in your station, and then you try to emulate that as best you can. So there's some books. Ron Block's The Grounds, and his new book, Lightning Protection for the Radio Amateur, is really good. And then K.A. Rand, another Polyphaser book. And the ARL Technical Information Service has a ton of really useful information. People don't know about the ARL TIS. They've been busy trying to deal with the hack and other stuff, and it's not real well publicized, but it's a tremendous resource, technical resource. Go to the technology tab on the homepage and follow that down to electrical safety and grounding and lightning protection, and there's a lot of stuff. Ron's papers are down there in the lightning protection. So we're going to take a break. I have some time for questions. If you have it, do you want to have them ask questions now?
It's only 10 after 3. We have till 3:35.
Oh, well.
So we got tons of time for questions.
Well, I blew through that. Okay, so let's have some questions. If we've got a field mic, can we take a microphone out there? We meaning you. Yeah. Hola. There we go. There. Come on up and talk into the microphone.
We're recording this session, so we need to get the clear questions.
If you're bonding your towers across the yard, can you bury your ground rods and your wires under the ground so you don't hit them with your mower?
Okay, the question is, if you've got a tower out in the yard someplace and you got feed lines and wires and stuff, do you bury them? What do you do, right, essentially? Okay, NEC says you can use feed line shields as your bonding ground conductor. Once you get more than about 50 feet from the rest of your house and your perimeter ground system, the ground is too inductive. That length of wire is too inductive to be helpful, but if you can bury it and it's bare, it's a perfectly good ground electrode all by itself. But I would not run an insulated or isolated conductor from a ground system through conduit out to your tower and expect it to do anything but give you an AC safety ground.
And a second question, when you buy power supplies, why is there not a grounding nut on them? Even though
okay, power supplies. Most power supplies are made to float. So you can actually connect them together and make like a 24 volt or something like that. And there is generally a terminal close to the output negative of a power supply. If you go in there and open the enclosure, you can find a terminal that you can connect to it. Sometimes there's also a ground terminal or a jumper on the outside. And if you want to, then you can connect the negative of your power supply to your system ground. Otherwise, it's going to float.
Hello. Yeah. My electrical service comes into my basement on one side of the house. My ham shack is on the other side on the second floor.
There you go.
My antennas are coming in on that side with a hand jack. All of the cables are connected to right angle copper. And I have, let's see, there's a ground rod right below there. There's a ground rod by where the electrical comes in.
Mm-hmm. So what do you do?
Yeah.
Basically, you get the heck out of that room when there's a storm. Okay, that's a typical worst case. That's very, very common. I get a lot of questions about that. Basically, you treat your station like an airplane. You would just want to bond everything in that station together. And if you can, bring your antennas down to ground level and put some kind of a panel down there. I have at home, and not at the big station, I have some external antennas. And I bought a little trash can, and I put a ground rod right through the middle of it, and I mount the arresters right on that. And so in comes the antenna feed line, and then it goes up the side of the house on the other side of the arrestor. It's too far from a top level apartment down to ground. That's too inductive. So it's not going to do you much for lightning. So basically, bond everything together upstairs. Don't run any of the ground systems through your house, okay? No ground conductors through the basement or crawl space. Don't invite lightning to flow through your residence or building. So that's got to all be outside. And then you just have to be careful. When it's stormy and stuff, you're floating. And I've got a second floor ham shack at home too, and I'm not in there when it's seriously storming. But everything's bonded together. Yeah.
I just want to thank you for your book and your videos because you saved my house. 3 top.
I'll send a bill.
Yeah. 3 top rail fence posts, had a vertical on top of that, and I had 3 ground rods at the bottom. I figured, give it some place to go. It won't want my house. That's exactly what happened. The lightning and the pole came a foot on the other side of my wife's head. Everything was good. Everything was fine. The other thing is I've been watching a lot of videos lately that I have a short, I use number 12 because that's what I just had, from my bus bar to every chassis of my computer,
Right.
my tuner, my everything. Is that proper? Because now I'm hearing people say, no, don't have to worry about it.
Oh, you got to worry about it, all right. It's when you have your grounds of your entertainment system and your computer and your telephone and your data service and all this other stuff, if they're not bonded together, when you wind up with a big lightning surge current that's flowing through the ground, something like that, they're all going to be at wildly different voltages. And that's when you hear stories like, oh, I was sitting there minding my own business and a thunderstorm came through and I saw the lightning and then there was this big green flash from my telephone to my computer and now nothing in the house works anymore. And you've got to bond your ground systems together. Whatever they're connected to, they have to be bonded together.
Yeah, I have seen people posting that you don't have to do that anymore. Not true. Bond and ground, it's critical.
Right.
If you want your equipment to survive. If you don't care about your equipment surviving, don't bond. You'll notice as moderator, I'm letting him do all the work.
So basically you said something about AC power protector. I assume that means like a surge protector.
Okay, the ones I'm thinking of, if you search for Isobar, ISOBAR, and they have a sub-brand called Triplite, or it's vice versa, maybe it's Triplite is Isobar. And you can buy these boxes. Some of them are two outlets. You just see two outlets. It's got a big power cord that you plug into something. Get the biggest one that you can afford or whatever, and typically they're 4,000, 5,000, 6,000 joules. They're rated in the amount of energy that they can handle. Some of them also have little indicator lights on them to tell you if they've been compromised. So, and then strangely enough, they don't come with a ground connector on them, but then they're not selling them mostly to hams. So what I use is I undo the screw from one of the outlets, and I use that as my ground terminal. I bond that to my ground system. So you're going to mount that thing on your ground panel, or your single point ground panel. It can be on the inside. It doesn't have to be on the outside, which is exposed to weather. And then so you're going to plug that in, plug the big power cord into whatever branch circuit you're using to supply the station. And then you run another circuit from the output of your protector to where your station is, and you power everything off of that.
Okay, so if I have the station on the second floor and I put this on my single point ground panel along with all my lightning arresters, should I have something outside close to the like where the coax?
I would move if you can, put your quote entry panel down at ground level as close as possible to your AC service. And then everything is bonded together there. And then you run protected cables up to whatever you use to get them through the windows.
Okay.
Okay.
All right. Thank you.
MOPs are single-use, one-time sacrificial devices. It'll protect you once.
Yeah, some of these things will protect you just once. And so you want to check them. I get the, let's see, Alpha Deltas and DXC, and they have little cartridges in them. And once a year, I go out and I unscrew the cartridges and I look at them. And it's very hard to electrically test them. You would have to take them to a motor rewind shop and have them do a high potential test. But if they've been compromised, you'll see some little char marks, or you'll see some little pits or tits on the curved surfaces inside the glass cartridge. If they're a sealed glass cartridge, it's opaque. Just replace them once a year. They're not expensive. You can buy a box of them from Mauser for about $1 a piece.
I'd like to add one comment about isobar. Because I do the same thing you do with the isobars, but isobars also have 40 to 80 dB of RF suppression in them. So it helps keep RF off your AC cables. So there's a reason why they're expensive. They've got RFI filtering as well as surge suppression in it, and they also have a warranty with them. If your equipment's damaged when it's plugged into them, they'll replace your equipment. So they're worth the money.
It's worth it. Yeah, and I want to make a note that what the power company calls common mode is common mode between the hot and neutral. They're not talking about common mode on all three conductors. So what we talk about as common mode is RF pickup that's on all three conductors. So when you're filtering, you want to filter all three conductors. And the isobars do that, and you can also wind your power cord on a ferrite core. Okay.
Thanks for what you do, Ward. Postage stamp size lot, inverted V fed at the corner of the property.
I can't hear you. There you go.
Postage stamp size lot, fed in the corner of a property, an inverted V, parallel feed line, coming into the shack, double pole, double throw, big ceramic switch to go to two different stations. When I'm not in the station, it's always in the neutral position. What else would you recommend for parallel feed line suppression?
Okay. Lightning comes from 50,000 feet in the air, and it comes to your double pole, double throw switch, and it goes, what? You know, it doesn't care. Okay, it's effective at switching the feed line. Yes. Okay, so what you can do is mount a pair of spark plugs on a grounded plate and run that ground right to a ground rod. Run your open wire line down to these two spark plugs, and then run your protected line up to where it comes into your station.
Great, thank you.
There you go.
I'd like to ask you some questions about proper tower grounding and coax cables on towers. And there's two situations that a lot of us have to deal with. One is continuous towers like Roan 55G, and then there's the telescoping towers where you don't have good electrical contact between tower sections. I've always read that you're supposed to ground your coax cable at the top of the tower and at the bottom of the tower, as close to the ground as possible.
Yes.
Before you start coming toward the house. So you might address how that works with a telescoping tower because of the joint issue.
Okay.
Also, do you have any experience with, there's a guy by the name of Knott out there who makes these lightning dissipators that go at the top of the tower. It looks like a big metal brush.
Yeah.
And supposedly that causes lightning to avoid your tower. Is that black magic?
Even the broadcasting industry can't decide about whether the charge dissipator things, they call them porcupines, how well they work. And some people say, I put one on and I don't get hit anymore. And some people say, I put it on and it hit the porcupine. It depends, like everything else, it depends on where the tower is located, what kind of storms you get, all this kind of stuff. It won't hurt anything. I'll put it that way. And maybe it'll work for you, maybe it wouldn't. But I would not recommend just a blanket, go out and get a porcupine and put it on the top of your tower. Okay, your other question about, okay, so you've got a tower, and we talked a little bit about inductance of the tower. You can think of the tower as a voltage divider, okay? An inductive voltage divider, inductive resistance. And if the lightning hits up here, you're going to get a progressive voltage drop down through the tower. The higher you take the feed lines off the tower, the higher the voltage they will be at during a surge. And even a little short piece of wire has enough inductance to make a significant voltage drop. 1 foot of number 12 hit with a kiloamp per microsecond surge will develop 761 volts from end to end, just a piece of wire. So you can easily get 100,000 volts between the top and the bottom of a 50-foot tower under a strike. So every 50 feet, basically, is the rule of thumb to bond your coax feed lines using a grounding kit or one of the grounding brackets. DXE sells them, and other people, where you actually cut the cable, put PL259s on, and you got a little bulkhead connector in the middle. Yeah, you got to go through all the weatherproofing and all that stuff. It's a pain in the neck. But you bond the coax to the tower every 50 feet or so, and that helps keep the coax at approximately the same voltage on the tower, and then you take it off as close to ground level or buried as possible.
Now, in the case of the telescoping tower, the cable hangs.
Right.
You really can't bond the cable to the tower other than at the top and at the bottom.
It's just a risk that you have to take. Luckily, there aren't too many telescoping towers that are really, really tall. So you bond at the top and the bottom, and that's about as good as you can do. Or you can make up some special clamps or something and just run a half-length cable down halfway, connect that, and that's bonded to one of the sections, and then the rest of the coax goes down to the bottom. And if you really want to, as you raise this thing, you can put on some kind of a stuff clamp or some other metal-to-metal clamp, and then run a jumper around the sections.
Okay. And I think the last question that I have is, I've been told that as many panels as possible, put one at the base of the tower where you have all your suppressors and lightning arresters and what have you grounded close, and another one at the entrance to the building where you are, and if you can, one close to the shack before you actually run the cable.
You've been at my station?
So this is a recommendation.
Oh yeah, I got some cheap surplus electrical boxes from somebody, and I have one at the base of the tower, and there's a lightning protection. I have an RCS 4L. It's a MFJ product, and they had lightning protection, which means gas discharge tube inside the switch. And so I had a remote switch, and I ran hard line out to the tower, and then I have 4 feed lines that come out. And also to the rotator cable. And here, I'm going to save you some serious money today. Save your money on the rotator cable. Don't buy the special multi-conductor, 2 different sizes thing that costs over $1 a foot now. Go out and get irrigation system control cable. A 10 conductor, number 18, you can pair up 2 sets of number 18 and make a nice number 16 out of it. And it's direct bury rated. You can put it right in the ground, and it's available. It's much cheaper than this stuff. And then at each place where you come up to your tower, for example, and you have a little terminal strip mounted on the piece of metal that you have in this box, and the piece of metal is grounded, and then you just put a gas discharge tube or an MOV or a Transorb or whatever you want to use from each line right to that panel with a sheet metal screw. I should have had a picture of that, but I have one of those at the base of each tower, and then I run everything into what I call the sacrificial barn, okay? And so I have a big panel in the barn, and I have more lightning protectors there, more stuff on my rotator control cables, and then I run stuff underground to the house, and there's a little dog house there, and I have another panel. And I knew I was going to get hit. I just wanted to wear the lightning out to the point where they get close to my house, and he's just like, so it's worked.
Okay. And there's no issue with going through all those arresters and everything. At VHF and UHF, you wind up increasing your attenuation, I believe.
If you get the ones that are properly rated, it adds a little bit, but not much. It's a trade-off. Can you take a 1/10 of a dB? If you're really, really, really high performance, you probably don't want to run a long run of cable anyway. You'll lose more in the cable than you will in the arrestor.
Thank you. Thank you.
You bet.
Hi, thanks for the talk. I'm asked a question. My station, it sounds like yours. I have a single point ground at the base of each tower. Every wire that comes off the tower goes to a surge protector. Cables go underground. They go to a second surge protector, single point ground at ground level where the wires come into the house.
Yep.
My station's on the 2nd floor also. You failed to mention anything about CAD welding.
About what?
CAD welding. For your grounds, isothermic ground bonding for the ground rods.
Yeah.
At my station, what I did is I started a perimeter ground around the building. I have a ground rod basically every 8 to 10 feet,
Right.
and that attaches to the AC ground coming into the house.
Yep.
And that's what I've done to allow for a better ground system on the building. The only problem I ever had was actually when the transformer across the street shorted a 12 kV line and put 12 kV into the house. In that case, I have a pull down device in the panel box which took the house offline. Mm-hmm. It has saved me a fire.
Yep, I just had a tree fall. You really do have a very similar station. I just had a big tree fall on my service drop. Okay, I didn't get into the whole ground rod thing, but basically I bought a big spool of number 6, and I found a buddy that had some surplus ground rods, and you space the ground rods approximately the length or twice the length of the ground rod. So if you got 8-foot ground rods, you put them every 15, 16 feet. You'll get real good. You get a lot of exercise, okay? T-post pounders are really good, things like that. And then you bond them together with clamps. You can use mechanical clamps, but then you have to inspect them every so often to see if they've loosened up. I got used to CAD weld. One-shots, you like fireworks? They're fun, okay? So I watched the video on them, and basically it's you ground rod, you put this little crucible on it, you cut the 2 things or 3 things that you want to bond together, you poke them in the crucible through little eyelets, you pour in the stuff. And then, well, not yet. And then you put a little shield on top, and then you put the lighting powder on top of that, and then the top of the crucible has a little hole in it. And there's videos on this, and I watched this, and I had never done one before, and I go, well, they must have really speeded that up because it just went poof like that. No, it goes woof, like that, and use a sparkler or a sparker thing, and it goes from 0 to 2,000 degrees Fahrenheit in about 2 or 3 seconds. And you wind up with a big ball of molten copper, and it welds everything together. And so you can bury that thing, and you'll never have to look at it again. And you just get good at it. 1, 2. Prepare to lose a couple. Prepare to sneeze in the top of the crucible and blow away the lightning powder. Don't ask me how I know that. Things like that. But CAD weld works really good. It's mechanically really sturdy, and building a good parameter ground system outside your house will save a lot of problems.
Very nice talk. Thank you. What do you do if you have a contest station in the southern Caribbean that's on a 330-foot coral mountain with absolutely no ground? We can't drive a ground rod 6 inches in the ground.
Basically, you have an airplane. You know, you bond everything together. And I talked to like the cellular guys that do towers.
I sent an email to you a while back about this.
Yeah, you know, and I say, what do you do when you put one up on top of these mountains, you know, that are all granite and stuff? He says, we just run big, long, heavy, wide straps out from the base of the tower. We have to, you know, we have to drill in and put some concrete in there, but we don't get a lot of mileage out of that. When the lightning comes, you can see the sparks flying off these things. I'm not sure I'd want to be up there when the lightning was coming, but they said you can really see it work. So the radials out from the base of your tower, buried or not.
Do you know how big to make these? Or
Oh yeah, he said it was like
we only have 11 transmit antennas and 6 receive antennas.
Yeah, well, they each one of them had like a 6-inch strap that was 30 feet long. So it's a lot of copper. You would simply stretch it out on the sand or coral or whatever you've got.
In all the directions that you can, right?
All directions, yeah. Just what does lightning want? Lightning wants to dissipate charge into the ground, and so give it heavy direct paths to do that, and that's as good as you can do.
All right, thank you. We have 3 minutes left.
Oh, I'm not going to do 3 minutes.
There you go.
I want to make a comment about bonding. I used to work at a TV station where we had balanced video lines grounded on one end. A quarter mile of that has 750 volts riding on it all the time.
All the time, yeah. And
So-
that, yeah, you can have, there's a static field from the surface of the earth up, and it's about, I think every 100 feet you get about 300 volts.
Yeah.
And so when you put the porcupines on your tower, and if it's a real high tower, you will see corona streamers coming off that all the time. And that's just from the geostatic field.
Yeah.
Yeah.
So that's all I want to say, and also good talk. Thank you,
Yep.
guys.
Just a suggestion: if you're driving ground rods, chuck it up into your hammer drill. It goes in very quickly.
Yeah, Black & Decker makes a really nice roto hammer, and the problem is when you hit a rock, and suddenly you and the rod and everything and the earth around you are vibrating, and then the rod kind of goes in like this. If you're in that kind of a situation, the NEC permits you to dig a trench, a shallow trench, lay the ground rod in that trench, and then bond to it like you would normally, or you can drive it in at an angle. But the important thing is to get as much surface area on the rod into your conductive soil as possible.
Okay, it looks like we got time for one more.
One more.
We talked about coral rock and trying to get effective ground. I live in Florida, sandy soil, water table typically 2 feet down. Putting ground rods in that, can you comment on what that does? I've never seen anything as far as measurements in terms of ground resistance, et cetera.
That's about as good as you can do. If you can get your ground rods into the water table, you're in pretty good shape. Yeah, it depends on the frequency. You know, at low frequency DC and AC, it's probably as good as you can get. And as you go up in frequency, you're going to get inductive effects and all these other things that'll make it hard for me to say. But the idea is you get a lot of electrodes into whatever ground system you've got, you bond them together, and make sure you've got as little inductance as possible, and that's as good as you can do.